Okay, we're going to take a look at the graph of y equals tangent of x. Let me quickly set up the unit circle. Hopefully remember tangent of theta equals y over x, which represents the opposite leg over the adjacent leg. Once again, for any reference triangle, obviously the triangle, the right angle is drawn back to the x-axis. There's theta, and so we have our y value for any point that is on the unit circle, and that is the opposite leg, and our x value is the adjacent leg. And so there's our point that's on the circle, and again, unit circle, radius of 1, and the radius represents the hypotenuse, which is not affected in the tangent. So we have some points here. Obviously, here's 0 degrees and 360 degrees. This is when x is 1, y is 0. At 90 degrees, we have x is 0, y is 1, and there's going to be some problems there as we try to divide by x. So when x is 0, that's going to give us an undefined value, and we'll take a look at that. And hopefully remember that an undefined value gives us a vertical asymptote. Here is 180 degrees. The point is -1, 0, and lastly 270 degrees, which is going to be 0, -1. Again, x is 0, we're dividing by 0, dividing by x, undefined, that's where our vertical asymptote is going to be. All right, let's plot some points now. So just from the points we have right there, so we have pi and 2 pi, -pi, and -2 pi. So here is pi over 2. We said x is 0. Well, let's graph that. We just said at pi over 2, it's undefined, so we're going to have our vertical asymptote right there. And 90 is the same as -270, which is -3 pi over 2. Okay, let's finish this vertical asymptote. Okay, and now down here, 270, where x is 0, that's 3 pi over 2. And we should start to see that that's at 90 and 270. Because it's periodic, this is going to continue every pi. There will be an asymptote, vertical asymptote. And 270 is also the same as -90, which would be right here. Okay, and where sine and cosine had a period of 2 pi over b, which when b is 1, that's 2 pi. Tangent has a period of pi over b, which in this case, b, which is the coefficient of the angle, in this case x, is 1, so it's just tangent has a period of pi. All right, so now what else do we have for values? So here I have, when I'm at 0 degrees, I'm going to get x to be 1, but y is 0. So it's going to end up being 0 over 1, which is just 0. So at 0 degrees, I'm at 0, which is also going to be at 360, which is also going to be at -360. When I'm at 180 degrees, which is pi, y is 0 over -1, which 0 divided by -1 is 0. And I'm going to get the same thing here. Okay, so what we find out we get for a graph, and I could do 45. Let's do 45. What we're going to find out, if I were at 45 degrees, that this would be 45, this would be 45. The two legs would be the same, so y over x is going to be 1. So at 45 degrees, and we'll treat this as +1, and this +2. That's supposed to be +1, and over here we'll get -1, -2. So at 45 degrees, I get a value of +1. At -45 degrees, down here, I would get -1. And our graph looks something like this. And it goes up forever and ever, gets closer and closer to the vertical asymptote without crossing. Same is true down here. And then we just keep repeating this over and over again. Okay, and that is the graph of y equals tangent x. And we'll do it 2 more times here. Make this one fit. Not a great graph there, but we get the idea. And again, how am I getting this? From the unit circle. And I'm using the relationship, the tangent ratio is opposite leg over adjacent leg, which is y over x. So for material we've already learned, and then a unit circle, which just gives us that information. Okay, next we're going to take a look at inverse tangent, which is also known as arctangent. Once again, we're going to go back and restrict the domain on the original function so that my inverse can also be a function. If it's periodic and it goes on and on forever, it's not going to be one-to-one, therefore I can't have an inverse function. So we restrict it, and in this case, let me go back here. We are going to look at the values from negative pi over 2, which is this asymptote, and pi over 2. And that's this asymptote right here. So we're looking in between those two. Okay, and so that's going to become the range, and I'm going to write that in our new function. So that's going to be our y values now, because that's our x over there. And our domain, because it goes on and on forever in our original function, had a range of negative infinity to positive infinity. That's going to be the domain of our inverse. So this will be negative infinity to positive infinity. Again, I don't need to write that down. All right, so let's go back and look at some of the points here. So we said when I was at x was 0, y was 0. So once again, when we go and change that, switch the x and the y, we get x0, y0. Let's come over here. When I had pi over 4, that was going to have a value of 1. Well, let's give ourselves, this will be positive 1, positive 2. So when I go over 1, I go up pi over 4. And hopefully remember that when I go to the left one, it's going to be negative pi over 4. Okay, and now these approached as I got closer and closer to pi over 2, it kept getting bigger and bigger and bigger. So instead of now as I go to 2, I'm getting closer and closer to pi over 2. So let's graph these, and it's going to look up like this, and then continue that way forever and ever. Wrong way. And continue that way forever and ever. And actually, I should have gone like this. Okay, and there's the graph of the inverse tangent x.